Solvents. SANOFI'S Solvent Selection Guide by Denis Pratt. The objectives of this presentation are to understand the industrial constraints linked with the solvent choice, understand the structure of SANOFI'S Solvent Selection Guide, be aware of the cultural differences between companies in terms of solvent selection, and identify the most undesirable solvents. As you know, the definition of a green solvent is not obvious. Some criteria are contradictory, such as the boiling point. A low boiling point favors volatile organic compounds, but on the other hand, a high boiling point complicates the recovery by distillation and is energy demanding. In other words, there is no universal metric set to compare the greenness criteria. In order to help chemists in their choice, some companies or institutions have edited solvent selection guides based on the following criteria: occupational health, safety, environment, industrial issues, such as the availability of a solvent, and regulations, such as on CMR. These guides have different structures and weighing of criteria, thus reflecting the policy and culture differences. After the merger between Sanofi and Aventis, the need for a solvent guide became obvious because we didn't have a common vision of the solvent desirability. The company was a complex mixture of research or industrial sites from the former Sanofi, Saint-Elabo, Rhône-Poulenc-Roher, and Hugs Marion Roussel, each with different histories, countries, and culture. Why a new guide after Pfizer's and GSK's? Because these guides did not satisfy us, mostly because the list of preferred solvents were too short, and because only a simplified version of these guides are published, and our chemists needed more details. Green Chemistry Institute Pharmaceutical Roundtable Guide is more recent than Sanofi's guide. We didn't participate to the elaboration of the Pharmaceutical Roundtable guide, but we are very active in its update. Besides, this guide did not satisfy us either. It doesn't give clear rankings. Sanofi's solvent guide consists of Word and Excel files available to all via the intranet. The maintenance is very easy. It contains one chapter on the physical properties. The aim is to educate lab chemists on the industrial constraints linked with physical data such as boiling point, melting point, flash point, auto-ignition temperature, specific heat capacity, and so on. For example, this scheme gives the boiling point versus the pressure and illustrates that solvent with a boiling point lower than 50 degrees under atmospheric pressure is not efficiently trapped by condensation, whereas a solvent boiling above 200 degrees at normal pressure requires a high vacuum to be recovered by distillation. This chapter is not publicly available. If you need more details, please apply for a job in Sanofi. The guide also includes two tables of azeotropes, which are not published either. One table, part of which is shown here, gives the azeotropes with water. The second table gives the azeotrope between solvents. It also contains a very useful table of physical data, which is on the laptop of process chemists. It gives 18 data on most solvents. For process safety, for instance, one has rapidly access to the boiling point, the flash point, the resistivity, and the specific heat. Sanofi's guide contains 9 chapters, for each solvent family: alcohols, ketones, esters, ethers, hydrocarbons, halogenated, aprotic polar, bifunctional, and miscellaneous, that is acids and base. In each of these chapters, here the aprotic polar, a paragraph gives an overview of the whole family, as both a table and a text. The guide offers 3 levels of lecture. The first level is a table overview, which gives for all solvents an overall ranking. recommended, substitution advisable, substitution requested, and even banned. Here, nitromethane for safety reasons. But not only, it also gives the ICH limits, which are very useful for the selection of crystallization solvents. The occupational health level, the safety hazard band, the environment hazard band, and also other industrial constraints. Note that all CMR solvents of category 1A or 1B are ranked at least as substitution requested, which is consistent with the European regulation. The second level of lecture is the ID card for each solvent. The color of the frame highlights the overall ranking. GHS hazard labels are given, as well as the most basic data: CAS number, internal safety data sheet number, boiling point, freezing point, flash point, and so on. A qualitative sustainability level is indicated, and a takeaway message is given. The third level of lecture consists of a paragraph on the solvent with full details: its synthesis, its use, its properties, and so on. The originality of our guide is the 4 levels of ranking: recommended, substitution advisable, substitution requested, and banned. This class of banned solvent is very useful. These solvents, such as benzene, carbon tetrachloride, or here diethyl ether, are not allowed for scale-up of new processes, even in the kilolab. What does this guide offer more than other guides? Clear overall rankings. These rankings are aligned with regulations such as CMR on ozone layer depleting agents. Simple HSE scores. The safety scores are aligned with the CLP regulation. The flashpoint limits are the same. The health scores are based on occupational exposure levels. The environmental score are based on ecotoxicological data. It takes into account industrial constraints. It is published with most details in Organic Process Research and Development. In conclusion, since the implementation of the guide in Sanofi, 2-methyl-THF, for instance, has become one of the most frequently used solvents in new processes, and aprotic solvents such as DMF are now rarely proposed, thus reflecting a change in the mindset of process chemists. Since its publication in 2013, the paper has been widely downloaded and already cited 36 times. It is probably largely used outside the company. Our guide, like any other solvent guide, is living. They take into account new regulations and constraints. They evolve, inspired by each other. As a result, they tend to homogenize, but some cultural differences will always remain.